Mr. Harris here, and welcome to a new video of Unit 11. In this video, we're going to learn how we're going to balance chemical equations. But first off, let me introduce to you what are chemical equations. So let's use an example of hydrogen. Right, do you guys remember the chemical formula of hydrogen? Yes, this is H2, and oxygen, which is O2. So you're going to use an example of hydrogen reacting with oxygen to form water. Okay, water is H2O. So in this reaction, hydrogen and oxygen are the reactants. So let me go ahead and write that down. These are the reactants. And water, of course, is the product. So this is the product. Okay, so far so good. So we write the reactants on the left-hand side of the equation. So as I mentioned earlier, these are the reactants. We write them on the left-hand side of the equation, and on the right hand side we will write the products, or if in this case there's only one product, which is water. Okay, and the plus sign, this denotes that you're reacting two substances together. For example, in this case we're reacting hydrogen with oxygen. And the arrow, please notice that it is an arrow facing the right hand side. It means that it is being changed to, or there's a reaction occurring, hence why. And it's also a single arrow. Okay, it's not like a double arrow or something like this. No, it's not a reversible arrow. It is just one single arrow that is going to the right hand side. However, we've already learned about word equations. Like over here, hydrogen plus oxygen, you get water, but it does not state the relative amount of each substance. So how much of hydrogen am I using, or how much of oxygen am I using, and how much of water is formed? So through word equations, I'm not able to know about these things. And that is why we chemists, we need to use chemical equations. So chemical equations will help us to understand these things in further details. Right, so let's have a look at an example. We're going to use the same example, hydrogen and oxygen to get water. So let's look at the equation down below first. The following chemical equation, it can represent the reaction between hydrogen and oxygen. However, this is not balanced yet. So in order to balance it, let's have a look at the diagram up above over here. So in the diagram, how many hydrogen molecules do you see? So over here, that's one hydrogen molecule, and this is the second hydrogen molecule. All right, so in total, there are two hydrogen molecules. So I'm going to go right in front of H2. And then how many oxygen molecules are there? There's only one there's only one oxygen molecule. So am I supposed to write 1 in front of oxygen? As I've told you earlier, just like in maths, the coefficient, when the coefficient is 1, we do not like to write it down. It does not look good. So we're going to just ignore it. We're not going to write it down, but we know that it's there. And finally, how many water molecules are formed? So over here, there's one water molecule, and this is the second. So I'm going to go ahead and write down 2 in front of H2O. Okay? So the balance equation now looks like this. You have 2H2 plus O2, you get 2H2O. Okay. Now, you may get confused now. You may say, Mr. Harris, what does this H2, for example, there's an 2 over here, and there's 2 here, there's 2 here. What do they mean? They're making me confused. All right, don't worry, guys. I'm here to help. All right, let's focus one by one. Let's talk about the big number 2. The big number 2 meaning the coefficient in front of H. This big number 2, it tells us how many molecules are there. Molecules. So in this case, when we look at the equation over here, let's look at the diagram. As I've told you earlier, there's one molecule and there's 2 molecules. So in total, there are 2 hydrogen molecules. Okay? And what does the small number 2 mean? So let me use a different color. Let me use red. The small number 2 is this one. Okay, that is what I mean. It tells us that how many hydrogen atoms are there in one hydrogen molecule. Okay, so let us focus on one hydrogen molecule only. So let us focus on this one. How many hydrogen atoms are there? There's one hydrogen atom over here, and that is the second hydrogen atom over there. Okay, that is the meaning of the 2. Same thing over here. There's one hydrogen atom over here, and there is the second one. All right, so in total, if I'm going to say how many hydrogen atoms are there in total, right over here. So when I go here, I'll see that there are a total of 4 hydrogen atoms. Okay, how about let me draw it over here. In 2 hydrogen molecules, there are in total 1, 2, 3, 4 hydrogen atoms. Okay, so let me write it over here. There are 4 hydrogen atoms. Let me try for oxygen. Okay, for the oxygen molecule, how many atoms does it have? So over here, this is 1, and this is the second one. So for oxygen, there are 2 oxygen atoms. Okay, now let's look at water molecules. So the red one, the red color denotes the oxygen atom. So there's 1 oxygen atom over here. And how many, let me use red over here. How many hydrogen atoms does 1 water molecule have? There's 1 and there's 2. Okay, so if I'm going to write it in the chemical formula way, so because there are 2 hydrogen atoms over here, and there's 1 oxygen atom, hence why the name is H2O. Let me look at the other water molecule. Same thing. I have 1 oxygen atom, and I have 2 hydrogen atoms, and that is how I get H2, 2 hydrogen atoms, and don't forget 1 oxygen atom. Okay, and because I have 2 water molecules over here, hence why I get 2 H2O. So in total, if I'm going to count in total how many hydrogen atoms do I have and how many oxygen atoms do I have for all the water molecules, let me write that down. So I'm going to calculate in total. So over here I have 1 hydrogen atom, 2 hydrogen atom, 3 hydrogen atom, 4 hydrogen atoms. Okay, let me write that down. So in the product I have a total of 4 hydrogen atoms. So a total of 4 hydrogen atoms in water. And if you look at the chemical formula, it makes sense as well. So 2H2, what does that mean? It means there are 4 hydrogen atoms. And let me look at how many oxygen atoms are there. There's 1 over here, and there's 2. Okay, so let me write it down. In the product, again, there are 2 oxygen atoms. So do you see? On the left-hand side of the equation, there were 4 hydrogen atoms and 2 oxygen atoms. These were the reactants. And in the products, I get the same. There are 4 hydrogen atoms in total and 2 oxygen atoms in total. So the left-hand side of the equation will definitely need to be equal to the right-hand side of the equation. So this is what this table is trying to say. On the left-hand side, there are 4 hydrogen atoms, which are over here. And there are 2 oxygen atoms, which are over here. And in total, you would get, let me use a different color. In total, you get 4 hydrogen atoms plus 2 oxygen atoms. Okay? So both sides of the equations, the number of hydrogen and oxygen atoms should be the same. The atoms will not randomly disappear during the reaction. They will just rearrange themselves to form new substances. Okay? And the numbers that we write in front of the equation to make sure that they are balanced, that is what we call a balanced chemical equation. All right? Just one more thing before I summarize this video. We would also need to add state symbols, the physical states to the chemical reactions. For example, if the chemical is a solid, whether it's a liquid, whether it's a gas, or whether it's an aqueous solution. All right? In the word equations, we're not able to know that, right? For a word equation, we would just have the words written hydrogen. Let me use this one. Hydrogen plus oxygen, you get water. It does not tell us whether it's a solid, liquid, or gas. But when we're going to use chemical equations, we will be adding this information as well. So let's have a look at an example. So over here, I know that hydrogen is a gas. So I'm going to go ahead and write down in brackets G. So something like this, 2H2, and in brackets G. So you would write it in the right corner, right at the bottom. And then I have oxygen. Oxygen is also a gas. And there'll be a reaction occurring. And then finally, the product is water. And water, we all know, is a liquid. Hence, you write L. Okay, I like to write it in cursive so I don't get confused with the letter I, because it might look like an I over here. So I tend to write it in cursive to let us know that it is the letter L. Okay, again, a reminder that we'll be using a single arrow to denote a chemical equation or a chemical reaction going in one way only. To let you guys know, actually, we also have a reversible reaction, and the arrow looks something like this. So this tells us that the reaction could go both ways, but we'll be learning about that later on. Okay, so this video sums up the introduction of how we're going to write the chemical equation. In the next video, I'm going to start doing some questions together, and I'll teach you more about that in the next video. All right, I'll see you guys in the next one. Bye.